Good day everyone, I'm Romel De Paz from EK31 of College of Engineering and Technology in Universidad de Manila, and I'm going to discuss to you about Batwing Antenna under Transmission Media and Antenna System guided by our Professor Engineer Brian Dineros. Before I start discussing about Batwing Antenna, let's just first define what is antenna. Antenna is a device that transmits and receives electromagnetic waves. It's an interface between a wave traveling in a cable and flying through the air. It's also important to understand that antenna works in both directions. You can have an antenna that only receives or only transmits. Let's now define what is batwing antenna. A batwing or super turnstile antenna is a type of broadcasting antenna used at VHF or very high frequencies and UHF or ultra high frequencies, named for its distinctive shape which resembles a batwing or bow tie. VHF is ranging from 30 to 300 MHz and UHF is ranging from 300 MHz to 3 GHz. And I know that you are already familiar with bats and bow tie, right? Bats are mammals of the order Chiroptera with their forelimbs adapted as wings. They are the only mammals capable of true and sustained flight. Bats are more maneuverable than birds, flying with their very long, spread out digits and covered with a thin membrane or a patagium. The bow tie is a type of necktie. A modern bow tie is tied using a common shoelace knot, which is also called the bow knot for that reason. It consists of a ribbon of fabric tied around the collar of a shirt in a symmetric manner so that two opposite ends form loops. Let's now continue with the batwing antenna. Stock arrays of batwing antennas are used as television broadcasting antennas due to their omnidirectional characteristics. So what is an omnidirectional? An omnidirectional antenna is a class of antenna which radiates equal radio power in all directions perpendicular to an axis or azimuthal direction, with, with power varying with angle to the axis or elevation angle, declining to zero on the axis. Omnidirectional antennas are widely used for radio broadcasting antennas and in mobile devices that use radio such as cell phones, FM radios, walkie-talkies, wireless computer networks, cordless phones, GPS, as well as for base stations that communicate with mobile radios such as police and taxi dispatchers and aircraft communications. Batwing antennas generates a horizontally polarized signal. The advantage of the batwing design for television broadcasting is that it has a wide bandwidth. It was the first widely used television broadcasting antenna. We are now done with the introduction about batwing antenna. Before we go further, let's test how much you have learned a while ago. Since batwing antennas are a specialized type of cross-dipole antenna, a variant of the turnstile antenna, let's just first define turnstile antenna to understand more about batwing antenna. A turnstile antenna or cross-dipole antenna is a radio antenna consisting of a set of two identical dipole antennas mounted at right angles to each other and fed in phase quadrature. The two currents applied to the dipoles are 90 degrees out of phase. The name reflects the notion the antenna looks like a turnstile when mounted horizontally. The antenna can be used in two possible modes. In normal mode, the antenna radiates horizontally polarized radio waves perpendicular to its axis. In axial mode, the antenna radiates circularly polarized radiation along its axis. For a turnstile antenna, the radiation power is 3 decibels below the maximum radiation of a half-wave dipole radiating the same power. Therefore, to overcome this disadvantage, the batwing or super turnstile antenna is built. The simple dipole elements in turnstile are replaced by 4 flat sheets in super turnstile. The design of super turnstile array is such that 1 to 8 bays can be constructed on a single mast. These images show super turnstile antenna. Figure 1 shows the arrangement of super turnstile array with the red dots being the feed points, and Figure 2 shows the stock turnstile array used in satellite communications. Let's now proceed with the design and characteristics of batwing antenna. Two pairs of identical vertical batwing-shaped elements are mounted at right angles around a common mast. Element wings on opposite sides are fed as dipole. To generate an omnidirectional pattern, the two dipoles are fed 90 degrees out of phase. The antenna radiates horizontally polarized radiation in the horizontal plane. Each group of 4 elements at a single level is referred to as a bay. The radiation pattern is close to omnidirectional but has 4 small lobes or maxima in the direction of the 4 elements. To reduce power radiated in the unwanted axial directions in broadcast applications, multiple bays fed in phase are stacked vertically with a spacing of approximately 1 wavelength to create a collinear array. This generates an omnidirectional radiation pattern which, with increased horizontal gain or more of the energy radiated in horizontal directions and less into the sky and down at the earth, suitable for terrestrial broadcasting. The batwing shape of the elements is used because it gives the antenna a wide bandwidth of approximately 20% of operating frequency at a BSWR of 1.1:1. This makes the antenna design suitable for broadcasters who wish to use a single antenna to transmit multiple television signals and thus made the batwing the preferred antenna for low-band TV stations in the early days of broadcast televisions. Before we continue with our discussion, let's test again how much you have learned. Let's now proceed with the batwing basic properties. The figure on the left side shows the general layout of a batwing dipole. It consists of dipole elements, each of which is fed from a common feed or phase line. The figure has also 3 pairs of dots indicating connection points. The most common implementation of the batwing, which we can also build from solid plates rather than from rods, use a central conductive mass. The top and bottom elements and the ends of the feed or phase line connect to the mass. Mostly as a form of lightning protection, antenna current on the mass is negligible. The center pair of dots form the feed point connection. Connecting the two terminals of the feeder to these 2 points connects the 2 feed or phase lines, the element in series with the source energy. The figure on the left side shows the distribution of current in magnitude terms only along the elements of a batwing at widely diverse frequencies, 375 and 475 MHz. The batwing is a very broadband antenna. There are slight differences in the current magnitude curves at these extremes, especially along the longest horizontal elements as well. The current magnitude shift at each connection point on the feed or phase line is also apparent. Stacking a pair of batwings. A popular use of batwings, especially when turnstile, is to create vertical stacks of them to increase gain. The figure on the left side shows the outline of such a stack along with 2 of the key parameters. The spacing between the centers of each array is limited by the vertical dimensions of each antenna. It makes no sense to have them overlap. So we shall be as concerned with end spacing as with the center-to-center spacing of the arrays. Here are the two principal applications of batwing. One of the application of batwing is the beam antenna. Using a planar reflector, we can obtain a unidirectional horizontally polarized antenna. Virtually any dipole-like antenna is suitable for use with a planar reflector, that is a solid sheet, screen, or set of closely spaced rods, forming a rectangle at a useful distance behind the antenna proper. Almost any size planar reflector that extends at least a bit beyond the boundaries of the driven antenna will provide some gain and front-to-back ratio. However, for many antennas, there is an optimum reflector size in terms of both width and height. The other application, which the Batwing is most famous, is as super turnstile antenna, often stock for greater gain. The nearly circular omnidirectional pattern has proven useful for commercial television transmitting. Almost any horizontally polarized antenna can be turnstile, and the Batwing is no exception. Of course, the most basic turnstile antenna consists of two simple dipoles at right angles and fed so that the current magnitudes are equal but 90 degrees out of phase. A similar treatment applies the folded dipoles to quad loops and to the batwing. This is almost the end of my discussion, but before we end, let's test again your knowledge about batwing antenna. Let's have a summary of our discussion. We have discussed about the definition of batwing antenna, that is also known as super turnstile antenna. It is a type of broadcasting antenna named for its distinctive shape which resembles a batwing or bow tie. The advantage of the batwing design for television broadcasting is that it has a wide bandwidth. It was the first widely used television broadcasting antenna. Batwing antennas are a specialized type of cross-dipole antenna, a variant of the turnstile antenna. We also discussed about its design and characteristics, some of its basic properties as a very wideband dipole antenna. It holds promise of being useful for applications in the UHF range, where we can make a good use of constant performance characteristics across a wide area of the spectrum. We also learned about the two principal applications of the batwing. The first is with a planar reflector to obtain unidirectional performance. The second is as a turnstile array to obtain omnidirectional performance. I hope that you have learned a lot about batwing. Thank you for watching.